All right, morning, guys. Yeesh. Yeah, I have no idea why. I'm here, don't worry. Okay, so what we'll do is nah, don't worry. I think not even the coronavirus can stop physics, so it's fine. Okay, so today's topic title is density. Sorry, wait, why is the that's better, yeah. So the topic title is density, and so those of you guys have your physics books. I have no idea how on God's earth I meant to enforce you guys using actual books, but yeah, try to use a physics book. Archie, if you don't have I don't know, for anyone who does not have their physics books, just use like a piece of paper. Okay, I got an idea. Let me just once again test lag test. Just write okay when you can see this. Just say okay when you can actually see that word or those two words there. Oh, okay. You're lagging about 10 seconds. That's all right. Okay, so let's start off. So today's lesson is quite easy. What? Some of you guys are lagging at least half a minute. That's tragic. Okay. So what we'll do is let's just go through these very quickly. Um, yeah, I think guys, some of you are lagging at least a minute behind. You're almost in a different time zone. So what I suggest is you guys refresh the live stream. Otherwise, you'll be like one whole minute behind. Anywho, so we're looking at density today. And before that, let's explore what we mean by mass and volume. So when we look at mass, and I want you guys to do this at the same time, right? So write down the units for these three, or at least what you think they are. So with mass, we know that mass is measured in kilograms. We went over that in class. We mentioned that it's how much matter is in something. That's that. Volume. Now, chemistry and physics use different units for volume, but physics is better, so we're going to use this. So we're going to use something called meters cubed. Yeah, so what we have is m to the power 3. Now, what we know is, let me actually get this out. If you look at this very quickly, this cube here, if you want to find the volume, you're going to do what? Like length times width times height or depth. So it's three-dimensional. Because something's three-dimensional, you are going to put the number 3 on top of it. You're pretty sure you know that from math anyway. So density, if the relationship between mass, volume, and density is this, very, very important. It's not going to be that long. Probably going to be like maybe 20, 25 minutes most. So I want you guys just to write this down. Let me put that notepad from class. You guys can't escape. If you see the notepad, you have to write it. So mass equal to volume times density. First thing I want you guys to do very quickly is just rearrange this and try to make volume the subject and then try to make density the subject. So this is the first formula. I want you guys to make volume the subject is the second one. And then for the third one, I want you guys to make density the subject. Yep, so I'll give you guys about 20 seconds or so. Oh, I think they put you in the year 11 classes since some of the year 11 work is relevant to you guys, since you're already doing your GCSEs. Oh, George, we're gonna go through that in a second. I first have to show you how the formulae work. Don't worry, I'm not just gonna leave it. So with volume, don't worry guys, I'm going back to that, I promise. With volume, is going to be what? Mass over density. I hope you guys got that. And then with density is going to be mass over volume. Yeah, so this is what we get there. So I guess tick your work if you got it correct. That should be really good if you guys managed to get these two. Now, to find the units for density, if the formula is mass over volume, all we need to do is, instead of these two, place the units there. So the units for mass would be kg over And then the units for volume would be meter cubed. So this is the units for density. That's simple. Because we divided this by that, your units are also going to be divided by each other. So density can be said as kg divided by meter cubed. Yeah, or kilograms per meter cubed. That's the units for density. Yeah, so hope is straightforward so far. But that's the units, and that's the formula. You have to memorize this for the exam, by the way. They do not give it to you in the GCSE formula sheet, so it's quite important. Okay, moving on. Now, if I show you guys this, whoops, I'll show you the answer, spoiler alert. Which one of these three do you reckon is the most dense? So if you look at A, B, C, which one do you guys reckon has the most density? Might be a trick question. Oh, never mind. Ruby already got it. Yeah. So C is the most dense because it has the most particles in this in the same amount of space. Excellent. Yeah. So what we're looking at is that the volume of each of these boxes are the same. You imagine they're roughly the same dimension. So volume is the same, but then density depends on how much mass you can fit in, right? So which one's the most dense? C. Which one has the most volume? Let's assume that all the boxes are the same dimension, so they all have the same volume. And then which one has the most mass? Wait, why did I write A for the most mass? Never mind, I'm just trying to see whether anyone will fall for it. It would be C for the most mass, right? C would have the most mass since it has the most particles inside it. So that's quite straightforward. Um, Now, in terms of density, I don't know if you guys do geography, but I'm pretty sure in geography they use terms like densely populated, which means, for example, London has about several million people in a very small area, so it's quite densely populated. Same with Tokyo. So that's how you can kind of look at it. All right, moving on. This is a very good drawing of the ocean. I have no idea if you even understand what's going on. So this is the sea. This is a bird, and that's a puddle of oil. And this is just some petroleum tycoon there. Now, the thing is, imagine oil companies, no, actually, do not imagine, they always do that to be fair. But let's say that an oil spillage happens in the middle of the ocean. Um, Very first question, which one do you reckon is more dense, oil or water? Could be Mr. McDowell. Which is more dense, oil or water? Yeah, very good. Yeah, oil is. And I'm pretty sure you guys are saying that because it floats on top of water, right? So for instance, if this was the ocean, we know that oil would basically be somewhere at the top there and just be sitting at the top. So that shows that it's less dense, yep, because it floats and you can observe it. Now that allows us as engineers, as scientists, to clean up spillage very very easily because of that property there. Okay, another thing they could ask you in the exam is explain how helium air balloons float. What we need to mention is helium as a gas is less dense than air itself, which means that it floats on top of it. Okay, now I may or may not suggest you guys do this at home, especially with lockdown. Supplies are limited, and I'd rather not be responsible for if your parents get angry with you. But if you do make this at home, use very small amounts, right? If you just get like a tower and say like you, for example, fill it with honey, milk, water, and oil. Actually, do not use milk because it's too expensive and it's too rare. I can't find it anywhere in the shop. So maybe not milk. Use something else instead. But oil, water, and honey, what you'd see is that basically, and maybe you can use some washing up liquid, but try mix it for and see what happens, like which one floats on top of which. That is a pretty neat experiment. Okay, this is very important. If you guys know it, then it's fine. If you don't know it, you can write it down. But in the exam, you have to know that less dense objects float on top of more dense. Okay, now since we always do practicals in class, I don't know how on earth I'm gonna do in my bedroom, but oh well. So let's imagine we got this cube here, right? Now, what we're gonna do is, and you guys can take down notes as well. What we're gonna do is we're gonna try to find the density of this, right? So what we're gonna say is, what you can write the subheading now is, find density of random cube. Now, what was that game called? It's called forgot the name of what Rubik's. Yeah, find density of Rubik's cube. Yeah, so that's what we're going to do. And believe it or not, you can get about up to 6 marks in the exam for this. So first thing is we need to talk about what equipment we need. Obviously, we need a mass balance. So what we can say is we need a mass balance to measure mass, to give you the mass. And then to find the volume, we're just going to use a ruler because this is a regular shape. So we can say that allows us to find the volume. And then to find the density, last step is mass over volume, if you guys remember the formula from the last page. So once you get these two, you just divide them and then you get density. All right, so let's start this very quickly. Why is it milliliters? What? Okay, that's a glitch. Wait, 1 sec. Sorry. There we go. So it's 124 grams. So what we'll do is we'll say that the mass is 124 grams. Unfortunately, in physics, we do not want grams. We want kilograms. That is true, Alex. So I'm hoping you guys know that to go from grams to kg, you have to divide by 1,000. Yeah, to go from grams to kilograms. So if you guys get your calculator, you're allowed to use a calc here. I stole this from school, but well. So you do 124 divided by, let's see, 124 divided by 1,000. You get, yeah, 0.124, right? So you get, so that's that. And then the last thing is for your volume, all you guys need to do is just pretty much just measure this. What on earth am I doing? Wait. Density of Rubik's. Oh, it says find. So if you measure this very quickly, you get roughly about, let's just assume is about 4.8. Yeah, roughly 4.8 centimeters. So what we can say is, this is a bit more complex because I'm hoping for maths you guys know that if you have a cube, you're just going to do what? Length times width. No, this pen's not working. Times height. Yeah, so we said that the length was what? 4.8 centimeters. The width of a cube will be the same as well. Imagine enforcing powers on here. All right, so you basically get this. Now in your calculators, what I want you guys to do is convert this into meters first, right? So if I said the length of one side is 4.8 centimeters, we want it in meters, not centimeters. So you have to divide by 100 because there's 100 centimeters in a meter. So do 4.8 divided by 100. And you get 0.048, yeah? So that will be one of your lengths, 0.048. So if I was to draw this again for you guys with the correct numbers, kind of looks like this. So you have 0.048 there meters, 0.048 meters there. So as you guys can imagine, the volume is going to be quite small if it's a meter cubed. So volume is going to be length times width times height. So it's going to be this times that times that. So all we do is 0.048. What on earth happened there? Whoops. Times 0.048 and then times 0.048. And then you pretty much get that, which is, okay, that's tragic. Wait, 1.11 times 10 to the minus 4. Yeah, so all I've done was I just found the volume by times in all the different sides together. Yeah, so you just get that. So that's your volume. So we got volume there, we got mass there. So let's use this formula here to find the density. So density is going to be your mass, which is what? 0.124 kg divided by your volume, which was that number there. And if you put this in the calculator now, Let me show you how you put this in, because to be fair, even some teachers don't know how to do it. So you basically 0.124 there, and then you got 1.1 times 10 to the minus 4, and you end up with this. Bam. So you get 117 kg per meter cubed. Yeah, so that's pretty much how you would do an experiment to find what the density of a regular shape is. For example, like a cube. Yeah, Ruby, I think, yeah, your answer is a bit more accurate. I just rounded stuff quite a bit. So that could be up to 6 marks in the exam, quite straightforward. What I'll do is, on Show My Homework on the bulletin, there's a worksheet which has a few questions. Just try those questions, and then after check your answers. What I'll do is, like, probably in 10 minutes to another video with all the answers, and you can just check your answers there and we're done. All right, so that was a very short lesson. I guess for next week we'll try to do the other required practical. See if we can do it with household equipment. But yeah, anyway, take care, folks. Bye.